Hi everyone. Thank you everybody for coming. Great to see so many of you here. So I'm Alexander. I'm a software engineer working in cybersecurity. I work at Palo Alto Networks in a team called Unit 42 where we look at threat intelligence. And this talk is about how you can attack your own code. And I had the idea for this talk because I work quite a lot with people called penetration testers. If you don't know what that term means, it's the industry term for someone who's an ethical hacker, so somebody who gets paid to attack software systems. And I noticed while hanging out with these people that the way they talk about attacking systems is really different to how I think we as software engineers think about defending systems. So I thought it would be a cool idea to try and learn how people hack things, try and learn how they attack things, and then use that to defend software a bit better. But I had some issues when I first tried to do this. I went on a website called tryhackme.com, and on that website you can learn how to hack things. But I found it really boring. Before I go into this next bit, could you raise a hand if you've ever hacked something? Okay, so a bit under half. I don't know how everyone here found it, but for me, I found it pretty boring. If you're hacking something, you don't really get to write beautiful code. You don't get to write stuff that you're going to maintain for years. You're kind of just looking for a vulnerability. You're looking for a foothold. And quite often, you might just copy and paste someone else's code from a vulnerability database, from something someone else has put together. It might not work perfectly, and you just have to get it to work. And it can be in any language. If I'm hacking, I don't care if it's in Java or C or Python. I just need to get access to the system. So I found that kind of boring and stopped doing that. But what the rest of this talk is about is a way where I think you can learn about hacking things without having to become a hacker. And that is what this next slide is about. So another quick story about some of the people I work with or I'm friends with who are penetration testers. Again, if you don't remember, that's someone who's paid to hack things ethically. If they fail or pass an exam, their salary can go up by 10 or 20% or down by that much. So it's a really big deal that they have to take certifications where they try and hack things all the time. So it's a little bit like being a doctor, I think. You have lots and lots of exams all the time, very regulated profession, because obviously it's a crime to hack things if you don't do it in the right and proper way. As a result, people write tons of blog posts to try and help each other with training. So they write a lot about how they hack things, how it went. And I think this is really useful if you're a software engineer, because it means you don't actually have to spend all that time learning a new skill set about how to attack things. You can just read these blog posts. So I'm going to give two examples here. One is this. This is a Medium page, InfoSec write-ups. And this is a collection of blog posts by hackers who talk through how they attack things there. And then this is a GitHub repo, which contains basically loads of malicious code. And all hackers put stuff there for the kind of payloads that they want to send to us, to the software systems that we build. So a ton of useful information there. And then the next stage of this slide, this kind of 4 stages of hacking is, as I understood from reading lots of these blog posts and trying to understand how people attack things, I felt pretty much everything goes through these 4 stages. So I'm going to explain this a bit with a metaphor. It's a bit like if you're a burglar trying to break into a house. The first stage would be enumeration. So if you're looking at a house, I've never done this, but this would be like, if you're, maybe you call them up to see if they're at home at a particular time or not. You go walk around the house, see if there's a window that gets left open somewhere. In the software world, that's going to be something like, what ports are open on this service? If it's a web app, what are all the endpoints? How can I get a foothold? It might be what version of the software is it running? This kind of stuff, looking for things that can help equip you to then find the right payload. So if we go back to the burglar example, a payload might be, like say you found a window on the second floor that was open. A payload might be a ladder that you bring one night to climb into the house and get in. If you're a hacker, it's going to be malicious code of the kind that is on that payload's all the things website. And very often, as we'll see later, that means you'd find something that just already exists. It matches a particular tech stack. It's already been hacked, and you just need to get the puzzle piece to fit into the right area. The next stage I'm going to call harvesting credentials. Again, in my metaphor, this would be like once you've broken into the house, you might be looking for keys. Maybe you want to find a room with a safe that has like a car key or a room to some other door. In the software world, suppose you've got a shell on someone else's server. That's going to be things like API keys, usernames, passwords, SSH keys. And the reason that you want these is typically for the next step, escalating privileges, where you want to break out and basically get more power, do more bad things. My burglar analogy is kind of going to fall apart a little bit here, but I guess it would be like if you then took the car for a ride, or you found someone's like pass for work and could go into the company office. So hopefully that makes sense. I think this is quite different to how we think about defending things as software engineers. I think often we'll do things like scanning our code for vulnerabilities, checking that we haven't pushed secrets to Git repos. All that kind of stuff I think is really useful. But those are kind of automated scans. It's very different to this much more kind of active probing way that an attacker uses to look at a system. So with all this in mind, I'm now going to go through and hack a Flask app in a way that is completely based off one of the blog posts, well, one and a half of the blog posts that I read while doing some of the research for this talk. I'll go through these 4 stages. And the idea here is to sort of try and show you that you can do this to an app that you've wrote. It's not that hard. You maybe don't even need to run the commands, but just with some of this knowledge from reading a blog post, you can really see how someone might actually attack you in the real world versus just running a scan of your app. So just in brief, this is a very simple and very bad Flask application. All it does is accept a query parameter from the search key here, and that just gets sent into this template. So this render template function is basically just injecting this string. And I'm running it in a Docker container on my local machine. And this, well, I didn't want to do a live demo because they kind of freaked me out, but I did this earlier. But that's why it's on 0000 here, so I can forward the port 5000 onto my local machine. And I've done it in a Docker container because you'll see a bit later. There are some. I wanted to talk about how you can break out of a Docker container because I think probably a lot of us these days are running production applications in containerized environments in the cloud, in Kubernetes, and this is the kind of stuff, therefore, that I think is useful to consider how somebody might attack. So the first stage, there are probably a few things I'll just touch on briefly before you get to this point, is you're going to try and go through a list of all the endpoints, see what kind of responses you get back, and just kind of map out the environment. When you're doing that, one of the things that you would really like to see is an endpoint like the only one this application has, a search one, where as a malicious user, I can send something and you'll get something back that processes your code. How you might do that is then you would fuzz it. So fuzzing is you basically spam an endpoint with tons of payloads in the hope that one of them is a hit. It's like a spray and pray approach. And this is done here with a tool called GoBuster. I know this is a Python conference. Unfortunately, this tool is written in Go. I think everything else will be in Python. And this fuzzes stuff with a word list. So another really useful thing that hackers use all the time is something called a word list. In particular, this GitHub repo called seclists, I would really recommend checking out. It basically contains tons of, a word list is just a list of strings, tons of strings that are useful for hackers. So another example might be like 100 most common passwords, things like that. And here, all you're doing, all this tool does, is just send a ton of requests to this search endpoint, and it replaces fuzz here with every word that you have in the word list. And this is what the output looks like. It's probably a little bit messy to see. I'll go in the next slide in a bit more detail. But you can see we're getting lots of greens already, which is not good. So, well, good if you're the hacker, bad if you're us. And here you can see the kind of payloads that someone's trying to send in this spray and pray approach. It probably looks a bit unfamiliar in a Python world. I guess dir you would probably want to use on Windows command prompt to see if that gets you a hit. Who am I on Linux to see who's running? But we can see this gives us a 500 error. So this is kind of not really getting us anything useful back. It's just crashing the app. But it's a problem that it crashes the app, because really this should send back a 400 error. This is like a badly formatted request that shouldn't trigger a 500 error. So it's already doing something. And if we know that, if we're the hacker, that's good, because it means we can send something and get something back that is not what it's supposed to be. It's not at 400. And from there, I've kind of skipped over a few steps in the interest of time. What we then want to find out is what is the right kind of payload to send to this application. So if we now know that it's running Flask, which would be maybe a reasonable guess if you're a hacker, a lot of things run Flask. I'm going to assume we just figured that out somehow in this talk. You can then look up, and this is from that repo I shared earlier, payloads all the things. What are the kinds of payloads that you send to the template engine in Flask? If you don't know the template engine, it's Ginger 2. And if you're the hacker, it's quite easy from here, because I can now look up someone else's work and see, OK, this is the syntax. Like if I send 7 times the string 7, I'll get 7 strings back. This is probably more familiar to us now. This is just like normal Python. And I know that if I get the result back based off what it says here, then I know I'm running Ginger. And once I know I'm running Ginger, I can then look for things to do nastier stuff. So this is what it looks like if, here we kind of copy the syntax from GitHub. We do 7 times 7, and we get 49 back. So this is great if I'm the hacker. I can now see, OK, you evaluated my code. The next step is going to look pretty funky, but kind of a lot more interesting, I think. This is some super weird code. This is exactly why I don't like hacking, because this stuff I find very strange, but it's kind of interesting. This now I got from one of the blog posts. This gets you all the objects that exist in Python from your payload. So this underscore underscore class underscore underscore thing, I think this means method resolution order, is going to give me a bunch of Python objects in a really horrible mess that looks like this. So this is basically everything that you could just like import in Python. I'm going to make that a bit bigger so you can see. And you can see here like token, instance method generator, like all these kind of built-ins. What's next if I'm the hacker? I've now done, technically what we've just done is called Ginger server-side template injection, because we're injecting a string that the server is processing. Next, we want to try and get access to the host. And to do that, because it's a web app, we need to open a new process to execute code on the host. So the Python object that does that we're looking for is subprocess.popen, so open a new subprocess. And that is what I'm doing in this next really horrible bit of code. The 342nd object was subprocess.popen. So once you've got that whole list, you can just process it, figure out which index subprocess is in. And now, just to check this works, I have run a ls command. So this is bad. This is what is inside the Docker container, a main.py with some requirements.txt. So this is a kind of check that we've done that. So now we can can do the next stage in those 4 stages. We're kind of fully done now with the enumeration step. Next step, if you remember, was credential harvest, the bit in my analogy of the burglar where you're getting the keys, or well, looking for the keys. And one thing that I think is interesting that I think I'm definitely guilty of, and I think as software engineers we tend to not think about that much, is every penetration tester I know runs env as soon as they get access to a host machine. It's literally the first command they run, just to dump all the environment variables. I think we're all super used to like 12-factor methodology, doing everything in environment variables. So it is really easy if you're an attacker to just get like API keys, usernames, passwords, because we so often store it in environment variables. And this would give you not very nice output. In my dummy app, I haven't got anything here, but I think probably a lot of us in production applications would have something like a Snowflake API key here, or something that, or like a service account credential in a cloud environment, which would be enough typically to, with a little bit of extra contextual information, like dump an entire database and leak all of your information. So once you've done that, the next stage is privilege escalation. This is a bit more advanced, this section, so I'm going to gloss it a little bit, but the main thing to bear in mind here is suppose you're attacking something in a cloud environment, in a container. Again, I'm just picking that because I think that's what a lot of runtimes are these days. You might want to try and get to, say, the node in a Kubernetes cluster, something that, and then see everything running in that Kubernetes cluster. How you do that is you basically need to mount the virtualized file system on the container onto your own machine. So you need to basically tell it, hey, like where you're mapping on the host all of these files, give that to me. And that's what this bit does. You can run a command called fdisk here that will give you a list of all the disk partitions. Again, gives you a really horrible mess. But the final command is you do something like this. So you make a directory, I've called it pwned, just to be clear, and then you would mount the host virtualization bit that maps container files to host files onto your own machine. If that got a bit difficult and hard to follow, don't worry. The point there is just that we need to break out of the Docker container in order to get more privileges. And the real takeaway for this is that you have to be root on the container in order to do this. And it also wouldn't work unless you run the container with this privileged flag. So never do that. I don't really know why you would do that anyway. But the bit to remember for takeaways later is that you need to be root on the container. You obviously cannot look at disk partitions and change them out unless you're root. So just a quick recap before I move on to some of the takeaways. We've gone through enumeration. That was, I focused a bit on fuzzing there, and then sending a payload with Ginger to Flask. Harvesting credentials, we looked at getting environment variables for that, and then escalating privileges, we looked at how to break out of a Docker container and move onto a Kubernetes node. So now we've gone through that, what are some takeaways that you could do to improve your own security in light of this? So one thing that I think is quite easy is it's not that difficult to just fuzz your own application. There are a lot of tools like that GoBuster thing, which you could use to just send against all the endpoints that you have in a web app. Even if you don't really want to go through the trouble of downloading something else, you could just look at one of those payloads repos and make sure that all of your data validation for incoming stuff doesn't allow things like those curly braces that were essential for all the payloads. And I think your validation is just going to be better if you know actually what do I want to not let in. Something else you can do that I'll touch on in a bit is not store things in environment variables. Even though that sounds fiddly, there are actually some quite kind of well-tested ways of doing that in cloud environments. And then another thing you can do is implement least privilege for a container. So if it's not very rarely does your web app actually need to run as root. So why are we typically running them as root? I think if I go on Docker Hub, almost all the default images look like they're running as root to me. So how do you change that? How do you make sure your container doesn't run as root? So this is how you can use Secrets Manager in GCP. Same thing exists for a lot of other cloud providers. You do need some environment variables in this example just for basic configuration, which I think is maybe a good way to think about this. I think environment variables are really good for configuration, less so for secrets. And then you make an authenticated call at the end here to actually get the secret, which means the secret is going to be stored in application memory. So if you're an attacker, it's really difficult to access something in memory. So that's much safer. This is more for reference, because I'll put the slides up later. This is a pattern for creating a Docker container in Python that doesn't run as root. You basically create a worker, install all your dependencies into a virtual environment, and then use a multi-stage build to copy that into the next container. But I'll put the slides in the Discord channel for that in case this is useful. Just to wrap up too, these are all the resources I use in this talk. So I really based this talk off these kind of blog posts that I was talking about. A lot of productive copy and pasting. And some fun ideas to finish off on. I think if you know this stuff, you can kind of hack hackers back. So we could send some fake response headers back to mess with them. We could say we're running a PHP app when we're running Flask. That would waste a lot of time. We could add fake SSH keys into our container. Again, that would waste a lot of a hacker's time. Everyone I know who works as a penetration tester is terrified of honeypots, but rarely see them. If you know what a honeypot is, it's like something that looks really easy to attack and might contain some juicy data. So like a misconfigured MySQL server. And you could just run that with fake data in a sandboxed environment and have it trigger an alarm if someone tries to attack it. Now you have an example of what vulnerabilities look like. I think that's something you could consider building. And yeah, that's it. Feel free to add me on LinkedIn and welcome any feedback.
Okay, first question. How do we sanitize the input before sending it to Jinja?
So there are lots of different ways of doing that. Probably my favorite way is with Pydantic. I think it's very good at input validation because it checks type hints at runtimes. But really, just doing anything is good. I think if you want a really basic way of doing it, you could just use a regex that only gives you like alphanumeric and kind of spaces or underscores. Most code needs like some kind of brackets or stuff like that to execute. Just that alone would help a lot.
Okay, thank you. Do you have any advice on how to secure NVARs without HC vault?
Yeah, I mean, I think a lot of cloud providers have their own secret managers that help with that. I think people are often quite scared of doing encryption by themselves, but Python has a really great cryptography package that makes that not always that difficult. I would recommend digging into that if you don't really want to use someone else's solution. Fernet is a really simple encryption algorithm that is quite easy to get spun up yourself. Be careful where you store the key, though, if you do that.
Can we assess the security through fasting tests in CI? Can you advise any tool?
So I think it's really good to test security in CI, but I think you have to consider what works well for automation and what doesn't. So in my view, things like checking for credentials that are hard-coded is a really good use case for CI. That you can scan a whole app like that. People like GitLab and GitHub, I think, have put out a lot of kind of query languages for looking at overall application security. I haven't had the best experience with those. I think it's very difficult to like fully automate how someone would actually attack it. I don't think there's a downside to it, though. I don't think it really hurts.
Thank you very much. We don't have any more questions on Slido. Anybody wants to pose a question here?
Actually, one that needs a little context, it breaks the 160 character limit in Slido. So you went into an alternative to storing secrets in environment variables that it basically means change the code of the application. Now, sometimes we operate applications that we don't control the code base of. So do you have suggestions for more secure alternatives to running, to putting secrets in container environments that don't necessitate actual code changes?
Yeah, it's an interesting question. I think obviously it's going to depend a little bit on the environment where you run your app, but to give you one example, in Kubernetes, you could maybe try and, I think you can, in a pod YAML definition, change where you could read them in from a config map in Kubernetes and then secure that. So then you have some of the Kubernetes auth built in about who does it. I think that would be a difficult, I don't know if that's quite a Kubernetes specific answer, but maybe not, to be honest. I think that's quite a difficult problem. I don't know if any, yeah, happy to discuss that later, yeah.
So maybe a question related to that. If you already have access to the process running everything, then you also have access to the RAM and you have access to the globals, particularly in Python. So it actually doesn't really make sense where you get the credentials from. At some point you have to load them into RAM and into the globals somewhere in Python, and so you do have access, regardless of where you originally store those credentials.
Yeah, that's a very good point. Thank you for the correction. That is...
I didn't want to correct it. I just want to make that point because you can do lots and lots of, security kind of, let's call it theater, right? If you already have access to the process that's running the code, basically there's nothing much that you can do, right?
Yeah, so this maybe relates to, I think, quite an important principle in security, that it is rarely possible to make something like 100% secure, but I think you can add way more friction in, and I think that's a good thing to aim at. So if we think often that software engineers are lazy, I think hackers are definitely lazier, and it is definitely harder to get access to a program's runtime and memory than it is to just run an env command. So I think that would be a more accurate statement of the benefit of shifting away from environment variables into memory, that there's more friction, and so somebody's just more likely to move on and attack a different target that's easier. I think you also touched on another point that, like, I don't think as developers we should get stressed about making something perfectly safe, because we can't. But I think it's good to try and just make it annoying and difficult for someone to attack.
Secure enough.
Secure enough, yeah.
Okay, one more question from Slido. Do you have any tools that you can recommend for static code scanning?
I have a feeling Palo Alto might have bought something that I'm supposed to recommend, but I think GitHub QL I've used and I quite enjoyed. I thought that was good, and was like free to use on GitHub and my own kind of personal stuff. So I would try that out, see how it works for you. GitLab also have a lot of container images they do for that, where you can take a peek and explore a bit more what's in there.
Okay, thank you very much.